Okay, so dilations and scale factor, kind of similar to the similar figures we talked about on the last notes, but just a little bit different. So a dilation is a transformation. That's this whole unit we're talking about transformations. And it's just the way that you would think of when you think of like transformers. Think of a shape transforming itself. So it's going to turn or get bigger or smaller. Something is changing with it. The first type of transformation we talk about is dilation. And the only thing that changes with dilations is the size. So that's why we look at scale factor. So a dilation is a transformation that enlarges, so gets bigger, or reduces, gets smaller, a figure by a certain scale factor. So the pre-image and the image are similar. So pre-image is your first picture they give you. Image is what they call the second picture they give you. Dilations always change the size of the image, always change the size. Image and pre-image are not congruent unless there's a scale factor of 1. So an enlargement means a figure gets bigger from pre-image to image. So that would mean that the scale factor has to be bigger than 1. So you're multiplying all of your points by something larger than the number 1. A reduction, a figure gets smaller from pre-image to image, so a scale factor less than 1. And like I said up at the top, the pre-image is your original image, your first picture they give you, and it's labeled normal. Usually it's letters. So A, B, C, D, whatever they give you. The image is after the transformation. So in this case, after the dilation, after the size has changed. And we label that with a little hash mark, not that gigantic, but with a hash mark to represent the new points. And for whatever reason, we call that prime. Okay? So just to give you an idea, if I gave you the point A as your pre-image, A is 1, 1. Then your pre-image, or your image, is going to be A prime. So then A prime would be whatever we multiplied by our scale factor. So say our scale factor was 2, so I would multiply both of those points by 2, and now that's my new point, A prime, so that little hash mark. To find the scale factor, divide the new by the old measurement or coordinate. So if we've got G equals 4, G prime equals 8, we would take the G prime and divide the regular G. So 8 divided by 4. And that would be your scale factor. So example 1, a triangle has vertices C, -2, -1, D, 1, 1, and E, 2, -3. Find the coordinates of the vertices of the triangle after a dilation with the scale factor of 2. So when we dilate an image, you're multiplying it since it's got that scale factor. Multiply it by whatever the scale factor is. So the rule, how it looks, so it starts out X and Y, and then when we transform it, we're multiplying each X by 2 and each Y value by 2. And so for C, now my new point for C, so C prime, is -2 times +2. So that's -4. -1 times +2 is -2. So that's my new point. And that's it. So then for D, same thing. D prime, 1 times 2 is 2. 1 times 2 is 2. And then for E prime, 2 times 2 is 4. -3 times 2 is -6. And those are your new points. You can plug them in here, but that's all you're doing. So example 2, a figure has vertices S13, T43, U51, and V21. Graph the figure and its image after a dilation with a scale factor of 1/2. So since it's got a scale factor less than 1, I know my new image should be smaller than my old image. Okay, so the dilation XY, and this is, I said it a second ago, this is what they call the rule, and so that's what it looks like. Every dilation looks like this. So your scale factor times x, scale factor times y. And it's telling you to multiply each coordinate by 1/2. So take a second in your calculator and do that. Remember, to do fractions in your calculators, you hit alpha, y equals, enter. So 1/2 times 1 is 1/2. 1/2 times 3 is 1.5. And keep going from there. So take a second and do that. Okay, so yours should look like this. I just realized I did some of them fractions, some of them decimals. I don't know why I did that. You can do decimals. 1/2 is the same as 0.5, and then if you were to plot your new points, you would have this little guy here. They've already done that for you though. So then look at example 3. This is where we're going to talk about scale factor a little bit. Zach has a toy bicycle that is 2 inches tall. An actual tricycle that is 16 inches tall. What is the scale factor of the dilation? So write a ratio comparing the height of the two bicycles. So we're going to compare the height of the actual toy, my new measurement, by my old measurement to find the scale factor. So the height of the actual toy is 16 inches. And the height of the little toy bicycle is 2 inches. And so 16 divided by 2 is 8 inches. And so the scale factor of the dilation is 8. Okay, just some practice problems. Determine the coordinates of the vertices of each figure after a dilation with the given scale factor of k. Then graph the dilation or the image. So k, in this case, is 1/2. So I'm going to write off to the side, I'll make these a little bit smaller, my new points. So J prime, K prime, and L prime. So that's what I'm going to get after I multiply all of these numbers by 1/2. So -4 times 1/2 is going to be -2. -1 times 1/2, -0.5. Same thing here. If I multiply 0 by 1/2, I still get 0. 4 times 1/2 is 2. And -4 times 1/2 is -2. -2 times 1/2 is -1. So in your calculator, you can use 0.5 or you can use alpha y equals to bring that fraction up. So then we're going to go ahead and plot this point. So -2, -1/2. So in the middle. And then, so that's my J prime, J with a little hash mark. K is 0, 2, so 0, +2. And then L prime, -2, -1. Ooh, those are awful close. So yours should look just like the original image, just smaller or larger depending on your scale factor. So same thing on number 2. My scale factor is 2. So that means R prime, A prime, I prime, and N prime. I'm going to take all of these points and I'm multiplying each one by 2. So for R, -2 times 2 is -4. 1 times 2 is 2. 1 times 2 is 2. So that becomes 2, 2. 0 times 2 is 0. -1 times 2 is -2. -1 times -1. Or -1 times 2, I'm sorry, -2. And -1 times 2 is -2. So that's all you're doing. Take each number, multiply it by that scale factor. And then take a second and you can plot your points. Okay. And you'll know you're right if your scale factor is bigger than 1. Remember, it's going to be a bigger image. So it should look like your old one, just larger. Same thing on number 3. My scale factor is 1/3. So P prime, I'm multiplying every single one of those by 1/3. Q prime, R prime, and S prime. And just a little hint, since all of these are divisible by 3, multiplying by 1/3, same as dividing by 3. So maybe you can do that in your head and it'll save you a little bit of time. So new points for P prime, because -3 divided by 3 would be -1. 3 divided by 3 is 1. And you can try it on your calculator if you don't believe me and you don't trust me, but multiplying by 1/3 is the same as dividing by 3, I promise. So Q prime, 6 divided by 3 is 2, 3 divided by 3 is 1, 6 divided by 3 is 2, negative 3 divided by 3 is negative 1, negative 3 divided by 3, negative 1, negative 1. And we can plot our points. Negative 1, 1, P prime, 2, 1, Q prime, 2, negative 1, R prime, negative 1, S prime. And pause, slow this down as you need to. I'm going kind of fast, so you can slow it down as much as you need to. And the last one for this scale factor is 3, so that means it's going to be a larger image, and I'm going to multiply all of my numbers by that scale factor. So 1 times 3 is 3, negative 2 times 3, negative 6, 2 times 3 is 6, 1 times 3 is 3, 3 times 3 is 9, 0 times 3 is 0. And I'm going to say don't worry about plotting those points because I don't think that these match the graph. So don't worry about plotting those points. Number 5, Keisha used a photo that measured 4 inches by 6 inches to make a copy that measured 8 inches by 12 inches. What is the scale factor? So she's got a photo 4 by 6 and she's making a copy that's 8 by 12. So remember to find scale factor, divide new by the old. And so I'm just going to pick one. I'm going to say 8 divided by 4. So that's 2. That's my scale factor. Number 6, David built a model of a regulation basketball court. His model measured so I'm going to draw a basketball court, 3.75 feet long by 2 feet wide. The dimensions of a regulation court, so in real life, it's 94 feet long by 50 feet wide. What's the scale factor David used to build his model? So we're going to take the new, or the bigger one, and divide it by the old. And I'm going to use 50 and 2 because those are small, easy numbers. 50 divided by 2 is 25. So 25 is the scale factor he used. And then number 7, the blueprints of Mr. Wong's house. His great room measures 4.5 by 5 inches. And the actual great room in real life is 18 by 20. What's the scale factor? So take your new, or the bigger one in this case, and divide it by the old. So 20 divided by 5. And that is a scale factor of 4.